Hello, everyone. Excited to be here. My name is Michael Irwin. I'm an application architect at Virginia Tech, as well as a Docker captain. I'm excited to be here with you today for this Docker Community All Hands session. This particular session, we're going to be talking about debugging your huge container images, and we're also going to just talk about some best practices of image building. I recognize that I did a similar talk at the last hands-on, but that was a lightning talk, and so we had to just fly through things. And so this is going to be getting a little bit more in depth, a little bit more demos, and show off some tools that I use pretty much, maybe not daily, but quite often to work through my container images. And if you ever want to follow me on Twitter or GitHub or wherever else, I'm pretty much at Mikeser87 everywhere you go on the internet. So with that, let's dive in. So for our session outline, the things that we're going to talk about, first, we're going to provide a little bit of background of container images and layers in case you're not familiar with them, and because that sets the foundation for what it is that we're going to be talking about later, and kind of the best practices, and helping us understand how we make our images better. From there, I'm going to provide a little bit of an introduction to a tool called Dive, and this is an open source product, or not product, but open source tool available on GitHub. And it's a fantastic tool, and we'll talk about it. And then we're going to get into some common image issues that I run into, as well as some best practices on how to fix that. And we'll use Dive throughout that process. All right, so first off, understanding images and layers. Let's talk about what are images, what are layers, how do they work together, etc. One of the best analogies that I didn't come up with this, somebody else came up with this. I don't remember who, so if anybody knows, feel free to put it in chat or whatever, but think of images like a pizza. You have to start with a base of some sort, and you're starting from that base, and then you're adding layers on top of it. You may add your sauce, your cheeses, your meats, any vegetables you might put on, and you're adding layers on top of it. But whenever you add a layer, you're not removing the layer from underneath, and so you're starting from the bottom and working your way up. And while I know it's a very simplistic example, it is a good way to think about it, that our images are going to be starting with a layer of some sort, and then we're adding and removing by adding changes on top of it. We're never modifying lower layers. Okay, so the way that this might look like a little graphically is something like this, and I recognize my head's chopping off the labels off to the side, but that's okay. So an image consists of layers of file system changes or snapshots. You can think of it that way. And each layer adds or removes, and we'll talk about remove in a second, it's really hiding files from previous layers. Okay, so when a container runs, what happens is all these layers are kind of mashed together into what's called a union filed system. And the container doesn't really know that there's multiple layers going on, but there are multiple layers going on, and they're all being merged together. So if I grab my laser pointer here, okay, so we've got layer 1 here that adds file 1, 2, 3, and 4. And layer 2 is maybe making a change to file 2 and adding a file 5. And so then when our container runs, all these layers being mashed together give us file 1, 2, 3, 4, and 5. And so whenever you pull an image or push an image and you're seeing those individual like progress bars for downloads or uploads, that's what's happening here. We're pulling and pushing these individual layers of file system changes. And a Docker file outlines how these layers are being created. So anytime that we have a copy command or a run command, basically what that's doing is it's starting a container from the previous the previous layer, running whatever command, and then it creates a snapshot of all the files that change, and now that becomes the base for the next layer, and it just kind of keeps going over itself over and over again. So how are file deletions handled? As I was kind of saying earlier, file deletions aren't deleting files, they're simply hiding them. So just like if I had a piece of paper and I wrote in pen, I can't erase that pen, but I can go find some really old school whiteout, and I can get whiteout and I can put whiteout on top of it, and then I can write something else on top of it if I want to. But at the end of the day, that ink is still there, and when I pick up that piece of paper and I carry it across the office, or take it to a friend or whatever, that original ink is still there. It's just been covered up. Okay, and it's the same thing with our image layers. If I have, again, using the example from the previous slide, so layer 1 has files 1, 2, 3, and 4. If layer 3 removes a file, so maybe a Docker file command to remove a file, etc. And we'll see an example of this here in just a second. This layer isn't modifying layer 1. It's only putting this little marker file in layer 3 that when the merge of all the layers occurs using the union file system, that union file system says, hey, I see this whiteout file, and so I'm going to therefore hide file 4. And so the container, when it runs, doesn't know that file 4 is there, even though technically that layer had it and shipped it. Okay. And so again, it's really important to remember this, that just because you remove a file doesn't mean that you're not shipping it. It just means that it's not visible to the final container. Okay. And we'll see an example of that here in just a second as we dive into some images. Now, Docker has built-in support to be able to view images and to find out what's going on. And we can use the Docker image history command to see how an image was built. And this will give us layer by layer command history of how an image was built. And we can add the --no trunk flag to view the full command. And yes, I find it completely ironic and hilarious that we use a flag that's called no trunk, a truncated flag, in order to not truncate the output. Anyways, kind of just a little funny thing there. But we can also use the Docker image save command to package up an image, and it allows us to save it to a tarball. So for example, if I were working in an air-gapped network, I could save the image on one computer, put it on a USB drive, go to another machine, and do a Docker image import to import that tar file, and I can move images to computers or to machines that don't have network access and can't pull things from a registry. So there are ways to load images that way. But this image save lets us kind of see what's going on in containers. So I'm actually going to do a quick little demo here. And what we're going to do is I've got a container image that's called the mystery image. And if I look at this image, and I know I built it a long time ago, we see things like nodes. Okay, this is a node image of some sort. I'm setting this work directory. I'm copying a lot of stuff in. I see an npm installer, and then I see, ooh, hey, I'm removing some sort of file. That's kind of cool. And then I set a default command. So actually, let's try something. If I do a Docker run, and I'm going to remove the container once it's done, Mike87 mystery image, and instead of doing the default command, I want to cat app source settings.js. And it's going to say no file. And just to make sure that it wasn't a .json or something of that sort, I can do the no trunk, and I can see that that's there. So I see in the final image that this app source settings.js isn't there, and if I try to run it from the container, it's not there. Now let's do something crazy here. I'm going to make a new directory, and I'm going to call this image explosion. Okay, and I'm going to do a Docker image save. Mike87 mystery image, and I'm gonna untar it. So tar, let's see, actually I'm not gonna, there we go. And so this is going to create a tarball of the image, and the image save creates an output stream and just writes it to standard out the tar itself. And so I'm immediately going to extract it, and that's with the pipe to tar xf, and then so this is reading from standard in. Okay, so now I've got this directory of stuff here, and I can look at the manifest.json, and I can see details about the various layers. And when we looked at the layers, let's pull up our history again. Oops, I didn't want the full version of it. That's okay. So the last one set the command, we do an expose, and then this npm install app source settings. The layers here are in order from first layer to top layer, and so it's kind of opposite order of what my image was showing. So let's take a look at this 8b52. Okay, and let's look at the layer.tar. I see all the npm install, the node modules and everything that were added there. Now, if I go to source, app source, and if I look in here, I see this whiteout file. So that's how the file is being removed. Cool. So now let's go up one more. Oops. And let's look at where it was actually being added. xvf layer.tar. And now I can see the file was being added here, and let's take a look at that file. Okay, cool. So it looks like that a developer, whoever made this, included a settings.js that had a DB user of root and a database password, a secret that shouldn't be seen. Now, of course, my final container image couldn't see the settings.js file, but this shows that just because you remove a file doesn't mean that you're not shipping it. And again, it's important to remember that with our layering. Once you create an image layer, that's it. And that layer's been created, and you can only modify it by hiding it in future layers. So let's talk about Dive for a second. Okay, so again, Dive is this great tool that was developed by Alex Goodman. If you're here today, hello, shout out to you. And it's available here on his GitHub account as well. And there's a myriad of different ways that he makes it available for you to download and install it. But for me, I find that the easiest way to do it is using the Docker-based approach, where he publishes as a Docker image here at wagoodman/dive. And I have found that the easiest way to do this is run it through the container. By mounting in the Docker socket, it can talk to your local engine. And so what that means is that it can analyze images that you build on your local machine that may or may not exist in remote registries. Okay, and so I can build an image, take a look at it, and then make some changes to it, build it again, dive into it, and I can keep this process going over and over again until I'm happy with it, and then I can finally push it to a registry when I feel good about it. One of the things that I've done on my machine is I've actually made an alias so that when I actually run Dive, it runs this whole thing, and so I can just type Dive Nginx, for example, and it'll run it through a container. And it's a lot easier for me to use it just by typing Dive rather than having to remember the whole Docker run command every time. So let's actually take a look at this, and let's do a little demo here. So I'm gonna just do a Dive, and let's just look at Nginx. Now, when this starts, it's going to kind of load the image and take a look at all those tars and all the image layers and everything. And eventually you're given a screen that looks a lot like this. On the left side, the top left here, where it's kind of focused right now, has a list of all the layers in this image. I get a little bit of layer details, the ID, the digest for it, and the command that was used to create this. In this particular one, it was, this is starting from an Alpine base, and so it's just starting from, adding all the stuff for Alpine. And then there's a little bit of image details. He does some image efficiency, and this is kind of a rough number of how efficient he thinks the image might be if he's seen lots of files that have been deleted and added later, etc. Now, this is a keyboard-centric layout here. I can press Tab, and then it puts me over into the right side, where then I can view current layer contents. Now, one of the things I typically do is I hide the unmodified by pressing Control-U. Now, since this is the first layer, there's nothing there, but if I tab and go now to the second layer, I could see all the things that were added or removed when this layer was created. And I can press the spacebar to collapse directories here. And let me see if I can zoom out just a little bit to get, there we go. So now I can get the file size in here. So I can collapse things. Okay, the Etsy directory in this command added 123 megabytes, and I can kind of navigate through and say, okay, hey, there was a something in the user directory that added 17 megabytes. Okay, what was that? Okay, 12 megabytes were in the lib directory. Cool. And so I can kind of go line by layer and see what was added in each layer, and what was removed, and where my file size is coming from. And so this is a fantastic tool, and I use it all the time. Okay, so now let's go back to my slides here, and let's talk about some common patterns, common issues that I see, and how Dive can help me solve this. So the first one is clean up as you go, and I think most of you know this one at this point, but each command that changes files in your Docker file is a new layer. And again, like we saw earlier, remove files, only remove them from the view of the final container. So if we look at this particular one, not long ago, I was trying to build a Vault container that I could use in my CI pipelines or as a kind of an init container to load secrets from Vault and make them available to my application. And so one of the first things that we looked at was, well, how do we make this efficient? So I purposely made this not efficient just to demonstrate here. So I'm going to start from Alpine, which is good base. I add curl and unzip. I run curl to go fetch a release from Vault. This probably isn't the latest release now, but that's okay. I unzip the zip file, and then I remove the zip file, and then I remove the curl and unzip packages because I no longer need them. Okay, so it seems pretty reasonable. But if I look at dive for that, I see a lot of file action going on here. So I add curl and unzip, which was about 4.5 megabytes, not huge. I curl the zip file, which adds 65 megabytes. Okay, that's got some size to it. I unzip Vault, which adds 187 megabytes. That's just the size of the binary. There's nothing I'm going to be able to do about that. And then I remove the zip file and clean up. Okay, and what's interesting here is that there's quite a bit of space just for removing stuff, which is pretty interesting. Okay, so if we jump back to our slides here, we'll see how we can clean this up. So by chaining the commands together, it allows, again, think of the file system. If I make all the changes within the same command, then the final set of changes that occurs within this run command is now minimized. Okay, so if I add curl and do everything and then remove everything, by the time this run command is done, the file system never has curl and unzip installed, doesn't have the vault zip, etc. And so it's a much tighter image. And if I jump back over to dive, this confirms that. Okay, so if I look at this 189 megabyte image, all I see is a little bit of APK cache stuff going on, and I see the vault binary at user local bin vault, but I don't see the tar, I don't see curl, I don't see any of the other stuff here, and my image is much tighter and much easier for me to ship around and reuse. Okay, so practice 2, clear your caches. Okay, many of our tools create local caches, and I think again this is a pretty commonly known one. APT is a big example of this. I do an APT update because the Ubuntu images don't have the package registry indexes in the container image, and so I need to do an update to go fetch those indexes, and then I install something. Cool. Well, if I actually accidentally just deleted the tab for it. That's okay. So let's go to the terminal, and I'm going to do practice 2 before, and so we'll see it. Just do the analysis real quick, and so this is the before where I'm not doing the caches, and we can see very quickly how much APT caches are taken up in the image. Okay, so if I jump over here and okay, let's kind of go through user bin. Okay, that's cool. var. Okay, wow, there's 33 megabytes in this var stuff. var lib apt list is generally what we're asked to remove in order to tighten things up. Well, that directory has 30 megabytes worth of changes. So just by clearing the caches, I'm clearing 30 megabytes worth of stuff here. So pretty cool. All right. And now it's also important to recognize that there are a lot of other images or a lot of other tools that have caches that you might run into. Yarn and NPM, well, Yarn's a big one of this. In order to speed up future installs, it not only installs the node modules in your local app directory, but also kind of caches them in another directory on the machine or in your container. And because of that, well, that means you're installing everything twice. And depending on how big your application is, that might be pretty large. So one of the things that you'll want to do is after you do a Yarn install, make sure you do a cache clear to clear your images. And again, you can see this in Dive if you install everything, you'll see that there's an entire directory that just has lots of additional caches there. This one I don't have a particular dive example for, but this is just a good practice to be using. Use multi-stage builds. And there's two different examples here on the screen, and I know my face is covering up one of them a little bit, but the one on the left here is doing a Java build where I'm going to copy everything in and I'm going to do a Maven package. Now, if I were doing this today, I would have additional flags on this run command where it would mount a cache directory at the /root.m2 directory. So that way, the first build, yes, we'll have to download all the Maven dependencies, but the subsequent builds will go much faster because it already has those dependencies cached. But anyways, that's okay. And then I have a subsequent stage here that has just the JDK, or just the JRE, and loads the jar file from the previous stage. Again, allows my final container image to be much smaller and much tighter. And the example on the right here, which again I know my face is cutting off a little bit, so maybe I can let me hide myself for a second. Okay. This example here, I'm going to do from node. And I copy in my stuff here, and I do my build, and then my final image, since it's just going to be static HTML, JavaScript, etc. I'm going to copy the results out of that and just put it into the web root of the Nginx container. So again, use multi-stage to allow your final images to be a little tighter and less stuff in them. Okay, all right. Now, this is one that I see used quite often, and people, I think, don't really realize it, okay? Remember that any changes to a file, when it's going through the snapshots, okay, any changes to a file, whether it's changes to the file contents or attributes of the file, will cause that file to show up in the next file system layer change, in the next layer. And so a big example of where I see this being violated is changing the ownership of a file. In this example here, we're copying, again, kind of from a multi-stage build. I'm copying a jar file, and then in the very next stage, I'm going to change the ownership so that the app runs as, that the app is owned by an app user and an app group. So we're not running as root, okay? And yeah, I know that I'm missing the user command to change the default user when the container runs. So whoops on that, but again, the focus here is on the copy and run, because now this run is changing the file attributes of app.jar, which means that it's now in a new layer. And it means I'm shipping this jar file actually twice. And depending on some apps, that could be a pretty significant size there. In fact, here's an example of one build that I recently did that was kind of doing this. So we copy the jar file, and we see that the jar file is 298 megabytes. And then in the very next layer, well, all we're doing is changing the ownership, which we see the ownership change to user 1,000. So there's just an ownership change, but now we're shipping this jar file twice, and it's adding 300 megabytes to my container image. So not insignificant here. So the easy way to do this is by actually moving the change ownership to the copy. And now when I do this, what this will do is a single layer that will do the copy and change the ownership. And then if I look at my, dive into it again, I only see one layer, and that layer has the app.jar with the right user ownership, and I'm only shipping the jar file once. Okay, so it's, again, looking at these little things of what's changing the file system, and am I potentially shipping things more than I want to? The final thing I want to talk about is using a dockerignore file. And this was recently something that a fellow colleague of mine ran into. He was like, I'm building my container images, but every time I build it, I'm having to push 2 gigs worth of stuff. And I'm like, holy cow, what are you doing wrong? And we look at the container, or the Docker file, everything looks right. He's using build caches correctly and everything, but something's not right. And while it wasn't a node project, there was something similar to this where it was copying everything in the current directory and putting it into the container image. And what had happened was he was running things local on his machine and for development, and there was a logs directory that just had tons of log output, debug output or error statements or all that kind of stuff during development. And every single time he was building, well, it was copying in those new logs, which added several gigs worth of data to his application. And another time in which I see this is a node project where you may see this and right after doing your yarn install, but now it's actually copying in all the node modules, and you're replacing all the node modules that you just installed, which may or may not have a different architecture. Node modules on my machine will be built for Darwin for a Mac, while those in a Linux container will need a different architecture. So could cause problems there. So use a dockerignore file to prevent files from being copied in. So again, you can use Dive or other tools to find out, am I copying more than I want to, more than I need to? And then use the dockerignore file to kind of tidy that up a little bit. And so with that, I say thank you. Thanks for attending my little session here. And if you've got questions, feel free to reach out. And I hope that you've picked up a thing or two. I hope you've seen how valuable the tool Dive is. Again, a shout out to Alex for building it. And if you want to, he is accepting GitHub sponsors and everything too. So feel free to help him out a little bit too. And with that, I'll say have a great day and enjoy the rest of the Docker community all hands. Thanks.